This is section 5.4, and we're going to get to the fundamental theorem of calculus. We have a couple of things here. The first thing is the mean value theorem for definite integrals. If f is continuous on an interval a to b, then at some point c inside a to b, f of c is equal to the average value of the integral. In other words, you take the integral from a to b and multiply it by 1 over b minus a. And here's just graphically, some point c, you're going to have an f of c that's equal to the average value at some point. And then down here, when we have the fundamental theorem of calculus, and this is the one that we're going to focus on. If f is continuous at every point in a to b, and f is any antiderivative of f, little f, on a to b, then when you evaluate it, which we did in the last section, from a to b of f of x d of x is f of b minus f of a, where you plug those in. So this is what this looks like when you do the f of b minus f of a. Remember, we had that line that we drew, the brace, and we plug it in. And so here's just an example to remind us. If you have the integral from 2 to 4 of x squared dx, the integral is x cubed over 3. Evaluate it from 2 to 4, meaning you plug in 4, and then you subtract, plugging in 2, and you get 56 over 3. And our answers are expected to be in fractions, so we will be doing these by hand. That's the way we're going to get those. Let's go look at our problem set. All right, this number 1 has been omitted from the homework, so we'll start here, and this would be your new number 1. So let's look here. Evaluate the integral from 0 to 2 of 3x times x minus 5. So you want to go ahead and do that multiplication. And so you get 3x squared minus 15x. When you take the integral, you get 3x cubed over 3 minus 15x squared over 2. That simplifies to just x cubed, and we have minus 15x squared over 2. You're going to plug in the 2, then you're going to plug in the 0, which in our case here will just give us 0. So 2 cubed minus this. And when we do this one, we get 30, so 8 minus 30 is negative 22. So we're going to do that with all these problems. 7x squared minus 6x plus 6 from 0 to 2. The integral is 7x cubed minus 6x squared over 2 plus 6x. We're going to evaluate that at 2 and subtract it, evaluate it at 0. When you plug in 0, that's all going to go away. So we just have plugging in 2. And we have 56 thirds minus 12 plus 12. Those cancel. So we have 56 thirds. Number 3, integral from 0 to 4 of 4x squared plus the square root of x dx. You want to rewrite this one as x to the 1/2. Don't leave it in radical form, x to the 1/2. Now when we take the integral of that, we've got 4x cubed over 3 plus, and then when we do this one, we're going to add 1 to the 1/2. So we have x to the 3/2 divided by 2/3. Let me write that out. All right, so that's what you have. You have x to the 3/2 over 3/2. But when you have a fraction on the bottom, you want to flip and multiply. So it becomes 2/3 x to the 3/2. So that's where we are with this. Evaluated from 0 to 4. Plug in, and your 0 is going to make all this go away this time. So when you're plugging in 4 times 4 cubed over 3, we get this. 2/3 times 4 to the 3/2. Well, 4 to the 3/2 is the square root of 4, which is 2. To the 3rd power is 8. So 2/3 times 8 is 16/3. We're just going to add those two numerators over 3, and there's our answer. Let's go to number 4. We have x to the negative 7/5 integrated from 1 to 32. So when we do this, it's the same idea. We've got to add 5/5 to this number. So that becomes x to the negative 2/5 over negative 2/5. Flip this and multiply. So now we've got negative 5/2 x to the negative 2/5 evaluated 1 to 32. We're going to plug in 32 here and subtract, plugging in 1. So 32 to the negative 2/5 is 1 over, 5th root of 32 is 2, 2 squared is 4, so it's 1 over 4. You could do that in your calculator, but you're going to need to be able to do it with fractions. So we've got this here, minus 1 to any power is just going to give us 1, so we have minus a negative 5/2. So here we've got negative 5 over 8. This becomes a plus 5/2. We need a common denominator. So we're going to turn these halves into eighths. 2 into 8 is 4. 4 times 5 is 20. So 20 over 8 and a negative 5 over 8 leaves us 15 over 8. All right. Now we have a trig one. Let's see what we're going to do here. Okay, so we have the integral from 0 to negative pi over 6 of 9 secant squared x dx. Now, secant squared, there is an integral rule for that. We're going to go ahead and pull the 9 through the integral sign because we can do that. And we'll just multiply it at the end. But the integral of secant squared is tan x. So we've got 9 tan x evaluated from 0 to pi over 6. So we have 9 tan pi over 6 minus 9 tan of 0. So the tan of pi over 6 is square root of 3 over 3. You can either look at your unit circle, or perhaps you have that memorized. Minus 9 times the tan of 0 is 0. And so we just end up with 9 times this. The 9 and 3 cancel and leave 3 up here. So 3 square roots of 3. Let's look at 6. We have another trig one. From 7 pi over 6 to 11 pi over 6, we're evaluating for cosecant theta, cotan theta. We actually have a rule for the integral of cosecant cotan, and it is that it is equal to negative cosecant. So we get negative 4 cosecant theta if you integrate. So now we're going to evaluate negative 4 cosecant theta from 7 pi over 6 to 11 pi over 6. And we're going to plug in, and the cosecant of theta at 7 pi over 6, negative 4 times negative 2. Cosecant is the reciprocal of sine. So the sine of this is negative 1/2. And you would flip it and you'll get a negative 2. And then at 11 pi over 6, it's the same thing. So we have positive 8 when you multiply here. Inside here we've got a positive 8, but it makes it a minus 8. So ultimately we have 0. All right. Number 7, another trig, and we do not have a rule that is for the integral of tan squared. If you look at your integral rules, you won't find that one. So we need to remember trig identity. Tan squared is equal to secant squared minus 1. So we can rewrite the problem as the integral from 0 to pi over 4 of secant squared x minus 1. So when we integrate secant squared, that integral is tan. So we have tan x minus, integrate 1, you get x from 0 to pi over 4. So tan of pi over 4 minus pi over 4 minus, and here's where you have to remember that evaluating 0 doesn't always negate everything, because we got some trig things. So we're going to have a value here. Minus tan of 0 minus 0. All right, so tan of pi over 4 is 1 minus pi over 4 minus, now the tan of 0 is 1 and then we have minus 0. So this part, tan of 0 is 0, minus 0. This whole thing does go to 0, but we had to plug it in because it not necessarily would it be that way. It does happen that tan of 0 is 0. So we have 1 minus pi over 4 minus 0. That's just 1 minus pi over 4. This one is omitted, so our next one, this is number 8 now. We have the integral from -5 to -2 of this. Remember, there's not a quotient rule, so you want to try to simplify. Y to the 5th over y to the 4th is y, minus 8 y squared over y 4th. That's 8y to the -2 dy. So now we're going to integrate. And so that this piece becomes y squared over 2 minus 8y to the -1 over -1. We're adding 1. And so we're going to evaluate y squared over 2 because of this negative here. And we're going to put the y on the bottom. So this becomes plus 8 over y. Those two negatives made it positive. From -5 to -2. We're plugging in -2 and we're plugging in -5. Here we get 2 minus 4. Here we've got 25 halves plus, that's a -8/5. And if we change this to common denominators of 10, we have 125 over 10 minus 16 over 10. And so you would end up with minus 109 over 10. So that's what this piece will become. So we have -2 minus 109 over 10. This becomes -20 over 10. So we have -20 minus 109 over 10. Final answer, -129 over 10. This one is omitted. So that one, so your number 9, your new number 9 is here. The integral from 3 to 8 of x to the pi minus 1. Well, x to the pi minus 1, it's just a number. So the integral of that is x to the pi minus 1 plus 1. Those cancel, so you're dividing by pi. So when we evaluate that, then we have 8 to the pi over pi minus 3 to the pi over pi. You could factor out 1 over pi and have 8 pi minus 3 pi inside it, and I believe that MathLab likes that answer. You could try it this way. Number 10 and number 11, we are going to be doing areas, and these will be, this is an important part. Find the total area of the region between the x-axis and the graph of y equals -x squared minus 3x from -6 to 4. So I graphed this in my calculator. I brought that little graph over here. Now these lines don't show up on your graph, but you've got this thing. So what we know, we're talking about our graph and how it relates to the x-axis. So from here, I'm going to draw up a line. So I've got this area, then I've got this area, labeled it B. I've got another line that I can drop at x equals -4. Somewhere down here it hits my parabola. So I've got 3 different intervals where I have to figure the area. And so you go left to right. So from left to right, I've got the integral from -6 to -3. And what you want to do, you want to put the thing that is on top first. Well, when you're looking at this area, the x-axis is top, and that's y equals 0. So this is 0 minus our function. Write that out that way. Then the b part, what's on top? The parabola is on top. So we've got -x squared minus 3x minus 0. And we don't have to write that. The c part, again, the x-axis is on top. That's y equals 0 minus, you have your function, and that's from 0 to 4. So we have 3 different areas to figure out, to plug in. and I did them separately. It's just a lot of fractions. So a equals -6 to -3 of this. That's the a part. So you'll evaluate -3 and -6, and you come up with 45 halves. You do the b part, and you get 9 halves. And then you've got the c, and you get 136/3. So here's your 3 parts. This was all just computation. And we're going to add those together, common denominator of 6, reduce it, you get 217/3. So the key part is to do a graph, sketch it, find your pieces that you're going to evaluate for your area, write out your integrals with the different limits of integration. These were given to us, except we didn't have we had the -6 and 4. We did not have this x equals 3 and x equals 0. Now, let's go over here. Let me grab the calculator. Okay, I grabbed the calculator and I put this -x² minus 3x here, and I put y equals 0, which is the x-axis here. So when I hit graph, I did a zoom 6, and I know that I need this because I really have this piece here and this piece here. But I need to know these limits here. What are these x values? So just do your second calc, intersect, and hit enter 3 times. So we got the x equals 0. For the second one, second calc, 5. Before I hit enter, I'm going to move over to that one, get close to it. You don't even have to be right on it. Hit enter 3 times there, and we get the -3. So in pictures or instances where you don't have all of the x points that you need, you can find them using your grapher. All right, so that would be number 10. Number 11, find the total area between the x-axis and the graph. So we've got this x cubed thing between 0 and 3. And so I graphed it, and I've got a piece here and a piece here. Now, I'm given the 0, I'm given the 3, but like we just did, I need to find this one. So you would put this cubic thing in the y1 and put 0 in y2, which is your x-axis, and you'll come up with your x equals 2. So we just have 2 pieces. This first one from 0 to 2 is x cubed minus 5x² plus 6x minus the 0. The second piece, the x-axis is on top, that's y equals 0, so we have 0 minus our function. Put your function in parentheses so that you'll know to change the signs. So when we evaluate and integrate, we've got from 0 to 2 of x to the 4th over 4 minus 5x cubed over 3 plus 6x² over 2. And we'll just plug in, and that is a -0. We don't have to worry about that. That one's pretty easy. We end up with 8/3. That's the first one. The second one, this became negative, that became positive, that became negative. You're still integrating, but you are integrating from 2 to 3. So you're going to plug in 3, then you're going to have a subtraction, and you're plugging in 2 to these here. So there's a lot of fraction stuff, getting common denominators, and I'm not going to go through every step of that, but we should end up with 8/3 plus this piece down here should equal 5/12. You have to get a common denominator. That becomes 32/12, and you have 37/12 for your final answer. So that is the work for that. It is sometimes a little tedious. You have to be very careful with your fractions, but that should get you through these integrals and area.